What in the world do matrices have to do with systems? Well, we can't answer that yet, but I will sort of keep you posted that they have a big connection. Okay, a matrix has a big connection to a system, and everything in this chapter somehow will go back to systems. Again, the assignment that you guys were working on yesterday, and you'll turn in either today or tomorrow. Obviously, that's the nuts and bolts of systems, but everything from here on out is going to be some type of application or connection to systems. I don't know what you're thinking when you see matrix. Maybe you're good. Maybe you're saying, what is that? Let me put a matrix up here that just gives us something to think about. We will do something with this so you can jot it down in a moment. I don't know if you need to jot it down yet, but here's a real basic matrix. I'm just going to fill it up with 1, 2, 3, 4, 5, 6. But it gives us something to look at, and that is to first realize that a matrix is always an array of numbers. Now, we don't do a lot of definitions in here, but that's an important one, that you realize what exactly is an array. An array is an organization, and it's almost always, as I've seen it, it's always organized in a rectangular form. So when we talk about an array, there's some kind of organization to the numbers. You know, not every group of numbers is an array. You could have a bag of numbers. If you've ever played bingo or done something with a game, there's a good chance that stuff's just in a bag. Okay, but a matrix is organized. Now, because it's organized, we can do stuff with it. And that's what we're going to spend today doing. We're kind of going through all kind of the basic ideas with matrices. The first thing is we can just simply talk about its order. Its order. There we go. Now, the order of a matrix is synonymous with the size of a matrix. I'm sure the word size has more meaning to you, but when I say order, that's the same thing as the size of the matrix. Now, if you haven't yet, you might want to jot down this matrix, because now we're going to do some stuff with it. As you're probably not surprised, we're going to discuss its order, which again is the same as its size. Now, it's always going to be row, then column. You may have heard this before, but you always want to see the rows and then the columns. Now, usually that's pretty easy, but sometimes we get it backwards. Make sure that you see that there are 2 rows. That means that this is a 2 by 3 columns. So this is a 2 by 3. Again, pretty easy. You should get that right every time. But if you would say it was a 3 by 2, that would give us some problems a little bit later down the road. It's not a 3 by 2, it's a 2 by 3. Okay, well, we're not going to do 10 of those because you'd probably be bored after the second one. So let's move on to matrix addition and subtraction. What you're going to see I'm trying to do today is try to do as much as we can with the minimal amount of problems. So now we're going to jump to addition and subtraction. Now, addition and subtraction is probably what you would expect it to be, especially if you've seen this before, but I want you to see the phrase I put up here, corresponding entries. Corresponding entries, I want you to know what I mean when I say that, when someone else says that. So I'm going to take this matrix, and if you're comfortable with what I'm doing, I'm sort of just building on it. Did you give yourself some space? I hope you have some space beside it to subtract. So we're going to subtract. And then let's just fill this up with some easy numbers. How about 9, 8, 7, 6, 5, 4? Again, just to keep it as easy as possible. So we're going to subtract. Now, addition and subtraction is corresponding entries. You might still want to just look, but you're probably not too surprised that I'm going to say that we're just going to take 1 minus 9, because 1 and 9 are corresponding. Basically, they're in the same position. So, well, that will be our first entry in our answer matrix. Obviously, 1 minus 9 is negative 8. And it continues in the same fashion. We're obviously going to take 2 minus 8. 2 minus 8 is corresponding, and we get -6. And maybe you feel like that you want to punch out the rest of those 4 answers. Okay, so you're just subtracting the corresponding entries. How'd you do? You should have a -4, you should have a -2, a 0, and a 2. And again, we won't do any more of those specifically because, like I said, you'd probably be bored after the second one. So let's move on to what's called scalar multiplication. Now, scalar multiplication once again, I'm kind of guessing once you see it, and maybe you already have seen it, but that you would have said, yeah, okay, it's just like simple distribution. Okay, but let's make sure that you realize, and if you're like, what's the word scalar? Like, why are you using that word? Why don't you just say multiplication? Well, that you're going to want to pay attention to, because by the end of this quick lesson, we're going to be doing a different type of multiplication. So just go with me here. Scalar multiplication. Cookies? Yeah, I'll buy a cookie. Thank you. Thank you. All
right.
Have a good day. All right. Scalar multiplication is going to be when there is what we call a scalar number in front of a matrix. Now, a scalar number is like a one-dimensional number. We've never really talked like this because all of a sudden today we are making up something that is two-dimensional. You see, the numbers that are in a matrix are part of a two-dimensional set of numbers because they have rows and columns. So when there's a number in front of a matrix, that implies something called scalar multiplication. Okay. Let me give you a little bit more of this problem because, as you probably can already see, I'm throwing some variables around, and that's on purpose. So we've got the variable y, and then, yes, the letter x is in here. We've got a 2x, a 2, an x, a 5, and a 4. And I'm trying to take care of something else in the middle of this problem, and that is we're going to end up making some equations. So here's some more numbers, trying to keep it as simple as possible, but I've got a y, a -2, a -22, and a -16. Okay, now, when there's a number in front of a matrix, you do what I would suspect you're thinking, you do simple multiplication. That's because it's a scalar number. So basically, everything in this matrix is going to get doubled. And we need to do that. So we get the new version. Again, everything just being doubled, not too hard, but be careful. 12, -6, 2x, and 0. And it's going to be the same thing over here, except I'm going to suggest that we not distribute a negative y, okay? Not a negative y, else we'll just have a negative sign. Actually, we'll have 4 negative signs in that next matrix. So just distribute y, keep the subtraction sign, and you're doing scalar multiplication. All right, now don't think too hard here. Nothing really happens except that we put the letter y beside everything, nothing really happens until we think about this overall equation. And this is something that you guys will do in a few days for a grade. That is, that you guys will be working with problems like this where you have to find x and y. You have to create some sub-equations that'll help you solve for x and y. Let me just kind of encourage you here that it's not too hard to do, because you can just pick something that contains y, like these corresponding entries. They seem to contain y, and what they really represent is a simple equation of the form 12 minus 2y equals y. Again, just a simple equation where 12 minus 2y equals y. And of course, with a little bit of thinking, we can find y. And maybe you want to do that. Okay, you should be deducing that y would equal 4. Again, just some simple solving here. Y equals 4. And how about x? Okay, again, you have options. As long as you're choosing entries that contain x. Okay, and again, you have options. A lot of people would choose this entry. They see it right away that it's 2x. But that means then that we have to correspond, of course, with those other two entries. And again, you can make up a little equation. Now, if you're kind of wondering, what's the point of all this? Well, just hang in there. There is a big point to all this. Right now, we're just kind of doing some mental exercise where we're thinking about how to make equations out of these matrices. So 2x minus 5y equals negative 22. That'll be solvable.
So you have to be given the answer to make the equation.
That is correct. You would have had to been given everything I gave you in the first line, especially what it's equal to. You would have had to been given what it was equal to do this. Okay, but if y equals 4, I assume that you're plugging that in for y, so we can get this thing to actually be minus 20. So 2x minus 20 equals negative 22. And again, with a little bit of math, we can see that x would have to equal negative 1. X would equal negative 1. Okay, now what I really wanted to show you was scalar multiplication, but we mixed in a little bit of mental exercise with basically setting up some sub-equations. Ready? I'm going to show you something else about matrices, which I don't, again, think you're going to find to be too challenging, but still important. And that is the idea of equal matrices. Now, equal matrices is probably what you would expect it to be, but to make it official, they have to have equivalent corresponding entries. If matrices are going to be equal, then the entries in them have to be equal. And kind of like what was just asked, if I'm going to do one of these problems, then I need to be given what is equal. How about this matrix with a 4 and then a y minus 3, a y and a 2, a 1 and a 0. And we're going to say that that equals 4x, 2x, 2, 1, and 0. Actually, I would encourage you guys to chew on this one a little bit. Just want you to kind of ponder, what would you do to find x or y? What is it that you would circle? Again, these matrices are equal, so the entries are equal. So which ones would you circle? All right, and I appreciate that you thought about it. I know some of you are thinking about it, but you still would like to see. And some of you, what you did was spot on, so nice job. Let's kind of just be clear here. If I circle 4, it doesn't really tell me too much, except that, of course, that they're both equal. So I don't really need to go there. It would be smarter if I go where the variables are. Now, if the variables are equal, trust it. If the variables are equal, then y minus 3 has to equal x. Okay, again, trust it. Now, as a student that you are that's been around math now for many years and you're taking this next year of math, it shouldn't alarm you too much when you see 2 equations with 2 variables. Again, it shouldn't alarm you too much because 2 equations with 2 variables, even if you didn't think of it this way, but it helps to notice it's a system. Okay, and obviously we just spent a couple days reviewing systems, and you might feel like that you have a good handle on systems, but it should be kind of natural for you to take this and kind of run with it. That is to maybe substitute or whatever you need to do. Okay, but this is a system which you'll be able to solve for x and y. See how it's going to work? We'll just put a 2x in here. Not too fancy, you've seen that before. Obviously, it's a substitution method. And again, with a little bit of math, if a little bit of rearranging, you should deduce that x equals 3. Of course, I can plug that back in and quickly see that y equals 6. Equal matrices, probably what you would suspect. But again, I'm trying to spice this up a little bit. In this case, we made a little system. Okay, now the last thing we're going to do today, I'll just kind of be honest with you, it probably is the one thing that, especially if you have not seen this, would be what you would not expect. Okay, like this could be new for you guys. And even if it's not new, most kids need a good review of this. And it's matrix multiplication. Now, matrix multiplication, let me again just kind of flavor this by saying it may not be what you expect. You're going to want to pay attention. It's not hard. It's actually kind of neat, but it just might not be what you expect. First off, matrix multiplication has this method to it. It's kind of like 2 steps. I'll explain them, I'll show them, but it's got a method. The method is that you're going to multiply a row to a column, and then you're also going to add. Even if you're not sure what that means, just listen that it's got 2 steps to it. You're going to multiply and add. The other thing about matrix multiplication is essentially the size of the matrices matters. I'm going to show you this, even though it might just look like a lot of numbers right now, but actually there's no numbers, but these would represent numbers. And then I'll explain to you in our first problem. If you have a matrix, it's got rows and columns, and you're trying to multiply it by a matrix that has rows and columns. Okay, well, there's some things that need to happen. First off, to do this, the number of columns in the first matrix has to equal the number of rows in the second matrix. It sounds kind of fancy, but like I said, we will do this with a problem, and you'll say, yes. Now, the other thing is that the outside numbers, that is the row of the first matrix, and the column of the second matrix, that will end up being the size of your answer matrix. Can you guys read that purple? I like that color, but it's maybe not as easy to read. So it's the size of your answer is going to be the outside numbers. I don't want you to have to copy down a ton of numbers. So I'm trying to minimize what you guys might be writing down. But here's two matrices. We've got some numbers in them, 3, 2, negative 1, 4. And then the other matrix has negative 2, 5, 0, 1, negative 1, 3. Whether you've seen this before or not, please don't do this. Please admit or say, okay, I know we at least don't do this. And that is that you don't just take 3 times negative 2. If that's all it was, then I wouldn't have built this up with so much hoopla. Okay, you don't just multiply the corresponding numbers. I'm sure you noticed that the number 0 wouldn't have anything that corresponds anyway. So what are you going to do? Well, what you're going to do is you're going to use this row times column method. And I'm getting a step ahead of myself here, because what we should do, first of all, is make sure that the numbers match up. What I'm talking about is the size of this matrix. So let me back up a step. This is a 2 by 2. So that's something that maybe you write down, maybe you just kind of think in your head. But the truth is, this one is a 2 by 3. Okay, now, if you were a little confused by what I showed up there, essentially these numbers right here have to be equal, and they are. Okay, so that means we can do this problem. The other thing is that the numbers on the outside end up being the size of your answer. Now, this is helpful because sometimes kids will like to think about the size of their answer. How do I think about the size of my answer? Well, I could prep a matrix that's 2 by 3. You know, I could kind of like make it the right size. Okay, now that's kind of the preliminary stuff. Here's the main event. Row times column. Really process this the first time with me. Row times column. That's the first thing it means. Now, as it says up there, you're going to multiply. If you're going to multiply, that implies that you're going to take the first entry and multiply it by the first entry. Now, a lot of people just kind of put that in their brain, negative 6, negative 6. But you're also going to multiply, you see what I did with my fingers? You're now going to multiply the next times the next. Well, that gives you 2. Now, there's 2 numbers floating around here, right? Remember, negative 6 and 2. You're going to add them. You're going to add them. And again, it's kind of like a 2-step process. So we have negative 6, we have a 2, and when you add them, you get negative 4. Now, negative 4 is going to go in this position. As most people would say, yeah, it's going to go right there, but it's because you multiplied the first row and the first column. You see, that number is in the first row, first column. So again, it's got to go in that position. It's easy when you're using chalk, but decide how you're going to do this in your brain. And some people will keep circling, because now what I'm going to do is take this row, but I'm going to multiply it by the next column. 3 matches up with 5. Multiply, you get 15. 2 matches up with negative 1. multiply, you get -2. What were those two numbers again? 15 and -2. Add, and we end up with 13. Now notice where I put 13. I put it in the first row, second column. At some point, you're going to feel like I'm ready to roll. Maybe you've already finished the problem. Maybe right now you're ready to roll. I just want to give you a chance to think. You should be thinking and seeing 0 and 6. 0 plus 6. And then the fun starts over. Now just be careful. Again, maybe some of you are ready to roll or you already finished the problem, but just be careful. -1 should be the first number you see. -2 should be the first number you see. So -1 matches up with -2. Make sure your eyes are looking that way. 4 matches up with 1. What should be 12?
Oh, wait, no, it's the second.
Good. I'm glad that you asked. I'm glad you're trying to match that up. Did you guys? Did you keep going? Again, I don't want to hold you back. You multiply. You match up with each column. Okay, so the first number should be a 6. The next one is going to be a -5 with a -4. -5 and -4 is -9. And then the last one is going to be a 0 and a 12. 0 and 12, of course, gives us 12. Let's talk about this a little bit more. Okay, I want to try to meet your needs, but again, I'm trying to also show you new things. Just keeping it simple so you don't have to think so much. Here's a matrix that's got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It's not 12, 34, and 56. 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12. Again, just keep it simple. 7, 8, 9, 10, 11, 12. Now, this kind of ain't your little brother's multiplication. This ain't your little sister's. This is matrix multiplication. Row times column. That should bug you. Okay, you should be like, wait a minute, it's not matching up. Okay, it's not matching up because this is a 3 by 2 and this is a 3 by 2. I mean, they kind of seem like they should work, but as we're trying to help you understand, they don't. Now, the reason you were shaking your head no was because these numbers weren't the same. Are you tracking with me? There were 2 numbers here, which actually is that number. There were 3 numbers here, which is that number. So again, I told that to you for a reason. You can't do matrix multiplication unless it's the correct size. Some matrices can't be multiplied. In fact, I'm sure we can make a lot that can't. Okay, well, that was easy. Once you do that, there's nothing to do. All right, last problem, hopefully. What do I got here? 1, 5, 0. This time I'm mixing it up a little bit. 1, 5, 0, -3, 1, 4. And last matrix to jot down today, -2, 6, 5, 3, 1, 0. Negative 2, 6, 5, 3, 1, 0. Do you feel like you can run with this? The only thing that I'll do, but you may have already done it, is circle how big is the answer matrix? How many numbers are you seeking? Okay, now, don't let this get you worked up. The first answer is negative 20. Check that. The first answer is 23. But some of you have negative 23 or a whole different number. It's 23. If you need to listen, that's because 1 goes with negative 2, 5 goes with 5, and then we have a 0. So it's basically negative 2 and 25. Negative 2 and 25 is 23. What about the other 3 numbers? Again, I want to be helpful to you. It's 21. Can I point? If we can, I'll point it. I know pointing is not always good, but I'll point at some numbers. And then how about the last one here? You should actually be getting 15 and then negative 15. Careful, if you didn't get one of those, don't just change it. Can you go back and figure out why? Can I point at something? This is matrix multiplication. Now, as we said a time or two, matrices, why all of a sudden matrices? Well, you got to come back for a few more days, and you will say by the end of the week, okay, I see why we have matrices. Right now, we're just kind of talking about the nuts and bolts of matrices. They do have something to do with systems. Okay, so kind of keep that in the back of your mind.